This conference will now be recorded.
Nagaland, sir.
Hello.
Yes.
Can you start now?
Participants, we request you mute your mic. I'll repeat. Participants, we are feeling some disturbance, so kindly mute your mic. So session is about to start. Any doubts and queries regarding technical, kindly post in the chat section. Samarashan sir, I think it's time, sir. We can start the session, I guess, sir.
Okay, என்னுடைய ரைட் ஹேண்ட் சைடுல சம்திங் இஸ் ஒரு பேனல் வருது, அதை எப்படி க்ளோஸ் பண்றது?
சார் உங்க மைக் அந்த ஐகான் இருக்குல்ல சார், அதுக்கு மேல ஒரு ரெண்டு ஆரோ கீ போட்டு டைவர்ட் ஆன மாதிரி இருக்கும் பாருங்க சார்.
It has come. Okay.
Okay, sir. Okay, sir.
So I will start now.
Yeah, yes, sir. Please, sir. Yeah, yes, sir. Sir, I'll go mute. If in case anything, you please call me, sir, or else you message me, sir.
Okay.
Thank you, sir. Thank you.
Okay. Good morning to all of you. I am Santhana Krishnan, Chief Technical Officer from Tamil Nadu Cable TV Corporation, and formerly Deputy GM from Telecom Training Institute, BSNL. Welcome to all of you for the ATAL training program on IoT. I am speaking from Chennai on behalf of National Institute of Technology, Nagaland. Welcome participants, and my session on Internet of Things, it will go from 11:30 to 1. It is an introductory subject. My job is to provide a foundation for all of you for leading to the next sessions in the coming week, coming days in the week. Now I will go to the slide, next slide. Now our agenda is the introduction to IoT, network of networks, evolution, then architecture, technologies, enabling standards, application segments, challenges, and we will summarize again. The objective of this program is to prepare all the faculty members the technological aspects of Internet of Things, making them aware of all the industry happenings as on today, make them familiar with the technological aspects so that they will acquire adequate competence level while they are delivering lectures to the students, and also guiding students during these projects and also for research. With respect to the research student, then we will make introductions and also give ideas how to do the research topics, emerging topics on IoT and the connected subjects. Okay, now we will go deep into the subject. Sensor, a temperature sensor is the sun, and then there is a sensor, and the sensor takes the that is the non-electrical signal, that is the light, and then converts it to the electrical signal, and that is fed into the circuit. It is a thing, we call it as a thing. It is a sensor, converts the happenings in the environment into an electrical signal. So that's what we call as a thing here. This is a sensor, like that. There are a lot of sensors are there. Temperature sensor is there, touch sensor is there, pressure sensor is there. In your mobile, you have a lot of sensors, GPS sensor is there, touch sensor is there, everything is there. Okay. Now we will start from here. The meaning of thing you have to understand here. Whatever device which is capable of converting the happenings in the environment and then converting you into an electrical signal. Okay, then it is called a thing in our parlance, and then we call it as a sensor. Okay, now in this slide, you are seeing there is a sensor on the table light, and then charges the battery, and then when there is sunlight is there, then the table lamp is now delivering the power. This is what a thing is converting this environment energy, and that energy is now going to be made use of. Now we're going to discuss about how the things can connect to the internet. We discuss. Just like God gives the sensible things, nose you are sensing, eyes you are sensing, ear there is a sensing, body you are sensing, like that. A lot of sensors are available. So they are programmable devices. That is what we have to very basically understand. Okay, and then that device, the sensor devices, the memory is very less, battery power is very less, and they are not having any address. Okay, so that we are going to briefly discuss. If there is no address, then how we are going to identify them in a network, all these things. Okay, now I want to make you aware that there are a lot of sensors available that are going to be, that has to be connected. Okay, the sensor they are going to be connected, whether internet is required or not is the question now. Sensor can be connected without internet, and that is the subject now with the wireless sensor networks. Many of you may be teaching, and the wireless sensor network process is the basic foundation for the Internet of Things. Now, more things going to be connected. The thing will be connected to another thing. Okay, so now for here you are seeing in the slide there is a weight machine is there. Okay, then there is a coffee dispenser is there. So there are sensors. The moment the coffee cup is filled up, automatically these sensor senses that it is coming to the brim and then stops flow. Okay, this is one model. Your weight, what you are measuring, it can be sent online at a distant end. The data can find out whether there is a declination of your weight and whether that leads to any health process and all. So that means the things have to be connected now. Now the question is, the things can be connected to another thing, and many things can be connected among themselves, which are very similar in the nature. But if they are in a group, the data has to be flown outside. How the data can be flown outside? So some outside connectivity is required. So now there are two things. One, the sensor can be connected among themselves. They are called sensor network. The sensors, they'll sense and then bring the happenings in the nature, happenings in the environment into an electrical event, and then consolidating them and then bringing them to a nodal point. Okay, at that nodal point, we come to know that what is happening outside. This is one point. When it has to be taken to the network outside, then the sensor network information cannot be taken outside. So that we are going to see now. Okay. See now, things can be connected to the things. Then people are getting connected to the things. See, that is what you are seeing here. There is an ECG sensor, then motion sensor is there, and then these things can be connected to the internet, and ultimately they can be connected to the hospital. Okay. Now, here you are seeing things, how things can be connected to another thing. there is a taxi, car taxi, Ola and other things you are seeing. The moment you switch on, now your position is coming to the Ola application, and then Ola application says that where you are and what you want to do. So this is how the things are getting connected to things. That is what you are seeing. Now here you are seeing the sensor networks. Sensor network, here you have to have some basic knowledge. Many of you would have done program classes and that. But anyway, I want to have a recollection on this topic. Here you find that my cursor is now 1 minute. My cursor now is becoming, so you are able to see my cursor. My cursor is showing the sensor. They are called the source. These sensors are connected one with the other, and then they are making it as a net, and then they are connected to a sync node. Now, what you have to understand here is the sensor, they find the value from the environment. So let us say now it is a forest monitoring system. Let us say the forest monitoring system, the temperature has to be monitored. The sensors, now what I am showing, it will find out the temperature in the forest in case the fire comes. Then it will be programmed. If the temperature is more than 33 degrees Celsius, you give an indication that there is a fire has already come, in what is the location at which the fire has come. This information, say, let us say, this sensor is on my left hand side, and the other sensor finds out it is 32 degrees, the other one is getting 33 degrees. All of them informations are consolidated, and it is computed, and average is found out whether it is really 33 or 31. Then there is a program, that program finds out and interprets the value of the program, that there is a fire or not. So the value has been collected by the sync node. So a node, a sensor node, which has got the capability of understanding the information coming from unaddressed node. There is no address for that. Whereas if that information has to be given to your mobile device, then we should know the address. That address, we call it as an IP address. IP address is for when you want to go on the internet. So a sensor node which is not having any addressable capability, then it is called a data-centric node, and it is a source node. Whereas a sync node is capable of understanding the data-centric information and also understand IP-centric information. So sensor nodes are data-centric nodes, and internet is a IP-centric network. And the wireless sensor, the sensor can be wired or wireless. So there are two categories. Wired sensor, if you are seeing the airport, the door opens automatically when you go near, then that is a fixed sensor. That's a wired sensor. Whereas in the forest fire type of environment, then when there is a fire comes and this in the forest, you cannot connect the sensors. So they have to work on wireless. So they are called wireless sensor network. These wireless network sensors forming themselves as a network and then giving the information to the sync node. The sync node has got the responsibility to send it to the internet. So internet, it is an IP centric. So converts that information and then finds in the address and then send it to the internet. So here, the wireless sensor network, they are low power devices. There will be more than one sensor connected. So this is the scenario in the wireless sensor network. Okay. In the Internet of Things, basic thing is a wireless sensor, and the network can be wireless or wired. So that is the point that I appreciate here in the Internet of Things. We have seen things can be connected to the thing, human can be connected to the thing, anything can be connected to the anything. So that is the scenario in which wireless sensor network forms the basic of that. Now, if you see the wireless sensor network here, it can work on any time, any place, and anything. Okay, they are called smart networks. In this the drawing, you find the region X is given. The region X, there is no address. So it is just given location-based. It is not an IP address. It is a location-based addressable thing. That means, what is the location-based address? That means, if I am sitting in your class, or sitting in a class, then on my right hand side, who is there? If you say on my right hand side, so and so is there, on my left hand side, so and so is there, knowing that my location, I can find out the location of the two people. See, this is called the location based address. In these sensors are having locations information in the region here, and then they are connected with the multiple hops, and then it is sent to the sync node. So what is the temperature in the area, region X? The temperature is given here 14.8, 16.1, 14.6, and 15.2. They are computed and then found out an average, and what is whether it is critical or not, then they are confirmed. Therefore, the network, they're changing, they are smart network, they are data centric networks in the case of sensor network, and the content oriented network. There are autonomous system. Now we have to see the things which are connected on the internet. Okay, it can have machine to machine, or it can have things to things, or device to device. So that is what we have to appreciate here. Now let us see now what is the basic understanding of Internet of Things. Now we have seen physical objects and the things which are converting the environmental information into electronic information. Then there the electronics is embedded in that. So for example, now your mobile phone, the touch information is there. That is a thing that is embedded within electronics, and there are software and there are sensor. Okay. Now this information has to go outside. We should require network connectivity. Okay. Now all these things are put together. Okay. That means there must be a thing, and it should have electronics embedded, and it should have software, and it should have sensor to convert the environment things, and it should have network connectivity. If all of them are combined and connected, and then they are going to work to collect the information and exchange the information, they are called Internet of Things. For that, backbone internet is required. So that is a global system where all things are connected, all network, whether it is a computer network or device to device, everything, when it is getting connected, then we call it an internet. Okay, now basically Internet of Things is a physical object of things which has an embedded electronics and having sensors and software and having network connectivity, and that is called Internet of Things. So that's the basic example. Now there is a that is a hairline difference between the machine-to-machine communication and then device-to-device communication in the Internet of Things. So that I will see in 1 or 2 slides. Okay. So now, when I say things, it is converting the electrical information, that is the environmental information, into an electrical thing. Whereas machine is not converting the environment, that is environmental information, into electrical, but it is converting electrical to electrical only. Now, if you are seeing a robo is there, robo is a programmed embedded electronics, and it has been programmed what it is to be done. And there is a say machine is there, machine to machine there is a it is connected. Okay, so they are all connected to a computer through a wired network through an M2M gateway. Then they are called a machine to machine communication. Now let us see a little deeper into that. If you say the machine to machine segment in my right hand side, basically I want to give one information. One mobile to another mobile, you have a SIM card. One SIM card is there, in another mobile, another SIM card is there. It is a machine to machine because there is a SIM card is a machine. Okay, this is called an MTM segment. Whereas a sensor is there. Say by let us say a bird is connected with a sensor, and it is flowing from one region to another region, and it is monitored. The sensor on the bird, GPS sensor, it is finding out the latitude and longitude whenever the bird is flowing. That is flying from one place to another place. That is connected through the network because it is a thing, and that is converted to information, and then that is converted into electrical information, and then transmitted into the this. That is an IoT. Okay, that is how the communication is different. The SIM to SIM card, or the bird which is now carrying information on a GPS sensor, that both of them, the scenario is different. Whereas see, now let us say now MTM uses the proprietary or non-IP based. If you see the industrial built, that is the robos, they use a non-proprietary information. They are not IP based. Okay, and they had their own protocol. Okay, if you see the things, okay, it is a physical object and they have a unique identifier and they are sensing and then sending the information from one point to another point. That is how the MTM versus IoT, they are different. If you see the hardware and software, MTM is more hardware and more embedded modules, whereas the IoT is more of software. Okay, that is what you are seeing on my right hand side. The robo which is now converting, that is communicating with this one. A robo lifting the say, containers to the ship. Okay, understanding whether the ship is full or not. Both of the machines. Okay, whereas the bottom, if you see, there is a say what you see in the bottom. There is a man and he has got a body sensor, and the body sensor finds out the temperature and send it to the hospital. So that is the job of an IoT. But we have to understand, MTM is the subset of IoT. Okay, that is what we have to understand here. MTM is collected, data is collected in point solution and often in on-premises storage infrastructure. That we have to appreciate. Okay, in contrast to M2M, data in IoT is collected on a cloud basis. And if you see the application, okay, MTM data is on-premises application. IoT data is collected on the cloud-based application. And in the next slide, it is more clear. Another one more slide is there on this. I want to make every one of you very clear. What is the boundary? Very clear boundary between M2M platform. What is the clear boundary for the IoT platform? Where both of them sitting together and then working. It will be very useful for you doing the research, because now IoT is no longer going to carry data, very less data. There are IoT platforms which is going to carry very heavy data, just like that is video surveillance on the say smart city and all. Okay. Now M2M is supporting the IoT as a low level layer. Okay, and then IoT platform is also supporting using the support of MTM. Now in my slide, you are seeing now everywhere cloud is there. It is an M2M integration. On the side there is a computer. There are machines.
announce பண்ணிடுறேன். Hello, participants. I think we found some network issue on the presenter side. So he will take a 1 minute, 1 minute break to connect to other Wi-Fi devices. So please be hold. We are trying to resolve the issue. Sir, I think
Hello?
you can start the session, sir, so that we can test it, sir. If in case any problem occurs, then I'll let you know, sir.
Yeah, now I changed to hotspot, AirTel hotspot.
Okay, sir.
Shall I start now?
Yes, sir. Please start, sir.
Okay.
Please start, sir. I think audio is fine now, sir.
One minute.
Yes.
Okay, coming back.
Sir, now, Santhana sir, now it is clear, sir.
Okay, good. Okay.
Please start from the beginning, sir.
Now I think I.
Sir, please.
No problem. I'll start from the beginning. Okay.
Sir, you can give a small recap, sir, from the beginning, if in case people are asking. And this session is by 1 o'clock, sir.
No, I'll do, no problem.
Thank you, sir. Thank you. Participants, I think because of audio issue, we are restarting the session from the beginning.
Okay, now welcome back. I will do small recap and internet, and then see the agenda. I think you already see. Then the objective of the program is to make all the faculty members to be very familiar with the nuances of Internet of Things, and then have some and the sensor takes the non-electrical signal.
Hello.
1 minute, something that is the light, and then converts it to the electrical signal. 1 minute. So now you see on the screen a sensor, a temperature sensor. Now I'm audible to you. Okay. Now all of you seeing the electrical signal and Internet of Things. We want to see on the screen. For Internet of Things, we have to understand the basics of sensors, and then you are seeing here this slide. You are seeing there is a sensor. Sensor on the table light, and then that charge the battery. Hello. And then when there is no light, now you see the different type of sensors here. And that hello, I am audible to all of you. Hello, I am audible to all of you.
Your
No,
voice is
sir.
not clear, sir.
Hello.
Your voice is cracking, sir.
Hello.
Sir, Nagaland here. Again, the voice is
Okay.
breaking a lot, sir.
Now I change
And
to
many
ATAL.
also saying,
Previous one was much
audio-
better than this, sir.
Yeah. Even initially this was good, but now it is very bad, sir. The
Very
previous
bad.
one was actually
Not
yeah,
even
yeah,
a
yeah.
single word is visible.
One
So
minute,
nothing
one
is
minute, one
Uh,
minute.
so nothing is
Santhana,
Santhana
audible.
Krishnan sir, are you using
Yes,
the
sir.
headset while you are talking? Headset?
Clip, no clip,
Santhana,
direct.
Oh,
sir.
direct. Okay, only direct should be okay actually. Not sure, sir, whether the internet connection is at your end is having a data rate issue or not.
Don't know, really. Where is the issue?
So now I will restart. Let us see now. See, I was now explaining this. What is a sensor, and then how it gives the display from taking the energy from light, and then the device converts that into electrical signal and gives the display. And then in this slide, I show how the battery charge from the light sensor and table lamp, and the table lamp starts lighting when there is a dark. And sensor does this job, and there are many programmable touch sensors available across the world, and then that makes the Internet of Things very easier now for us. Okay, now more things are getting connected, and I was giving an example of the teacup, and the teacup becomes full, and then the sensor finds out and then stops the filling up of this one, and that is how more things are being connected in our life. And then now people are getting connected to things, and then there are motion sensor and ECG sensor, and they are connected to the internet. Now, like humans are getting connected to the network, things are also getting connected to things. And the example is the car example I gave you, and then the Ola and other cabs with what they are using this one. That example I was explaining. Then coming to the sensor, form as a network. Here, very important thing that I was telling that is a sensor, the source which is collecting the information from the environment and converting into electrical energy, and then collecting them and giving to the sync node, and then sync node which is capable of converting that data-centric information, because there is no address in the sensor node, and that is being sent via gateway to the core internet network. They are low power devices. So for Internet of Things, the sensor network is one of the very basic things, and we have to become a master of that. In this, how the temperature is getting converted. Now you are seeing the sensor network region, and the temperature is there 14.8 to 15.1, 14.6, and all coming. So it finds out, each one of the sensor finds out the event what is happening in the environment, convert them into the temperature, and then send it to the nodes. Okay, in the wireless environment, and multiple hubs, and giving to the sync node. So this is how the sensor networks are working. They are called smart network, and they are data centric, and they are only working based on the content. For each network, there will be for one application. They are application oriented network, and they are also context aware autonomous system. Then we came to the very important point is this Internet of Things, and here the physical objects, which is getting the information from the environment and then converting to the electrical thing, which is called the things. They are having embedded electronics. They are also having software. Okay. Whether my voice is okay now?
Sir, clear, sir.
Whether my
Please
voice is
continue.
okay?
Sir, it is
Okay,
clear, sir.
okay.
Please continue, sir.
Oh, good, thank you, thank you. And that this is called basically the Internet of Things. And machine to machine and IoT, there are two different terminologies are there. We have to be very clear and the demarcation of things, because whenever you do the research, and this demarcation is very important for you to clearly do research and the area in which you are going to choose. One is the M2M area network, another is the IoT area network. M2M is going to ride over the IoT network. IoT is the things which is getting connected to the network. M2M is the machine which is going to convert it into this one. Very classic example of M2M network is a SIM card. When one SIM card in one machine and another SIM card in another machine, they are M2M. A temperature sensor in a forest area is an device which is getting that, this is called a thing that converts that environmental heat energy into electrical impulse. So that is the thing. So that is how we have to appreciate the M2M and the IoT. More deeper into that, okay. The M2M and IoT, they differ how the communication is taking place. And they are M2M is the proprietary and they are non-based IP communication. Here we have to very clearly understand what is IP-based communication and what is non-IP-based communication. See now, when you make a phone call, you must know you must have a telephone number and you must know what is the destination number. That is phone-centric, number-centric network. When you have a computer, when you want to send a mail to another person, both the source and then destination, you must have an IP address. This is called IP-centric communication. When there is a sensor in the forest, gets the temperature information, there is no IP, there is no address. But that sensor belongs to a community which is capable of finding out the temperature, environment information in terms of a temperature and then find out. Suppose now you go to airport and you put your leg and the door opens. That is a pressure sensor. The pressure is the event, that is environment information, and that is getting converted. That pressure is getting converted into electrical information, and that is made to open the door. So that there the difference between the IP-based communication and non-IP-based communication. All sensor networks are non-IP, data-centric. All other internet-based networks, they are all IP-centric networks. And then the things in IoT refers to physical objects, whereas in M2M, it is a machine, okay, it is a proprietary information. Then M2M system, in contrast to IoT, it is homogeneous machine type within an M2M network. Okay, now M2M is more hardware oriented. IoT is more and more is a software oriented, and M2M is a collected point solution and in-premises storage infrastructure. In contrast to M2M, the data in IoT is collected in the cloud. Okay, that is why on my right hand side you are seeing M2M and then IoT. M2M, there is a robo, there is a container lifting robo, and then the ship is there. Both of them are in both places there are machines. Okay, and they find directly correspond to the internet through internet token, and then finds out whether the container is full in the ship, whether some more container has to be lifted or not. That is how you have to look at this M2M architecture. M2M architecture, and also find out the difference between IoT and M2M. Ultimately, both of them are going to sit together. That we are going to see now. M2M data is collected in point solution and be accessed by on-premises application, whereas IoT is collected, the data is collected in the cloud, and then it is going to be accessed by the cloud applications. So that is how we have to find out the difference. Now you see the diagram here. M2M is a low level. That is M2M is supporting by IoT as a low level layer. IoT performs that platform that can be using the M2M platform. M2M support. Now here you are seeing there is a smart equipment, air conditioning and heating is there, people traffic analysis is there, vending machine are there. On my left hand side, all of them are having sensor. The sensor converts the information and gives to cloud, and they are going to the M2M. Their MTM, what is MTM? Computer is there, laptop is there, mobile is there. That information is received by the machines. Therefore, that they're all machine communication. Here it is the things. The thing can communicate with the machine, and the robo which is lifting the container in the shape, they are from machine to machine. In this example, you are seeing a smart equipment which is having a sensor through the gateway, going to the cloud, and then going to the machine. Okay, this is how it is going to work together. Now, here more clarity is given. Okay, now car, there are devices. That is the example sensor. It is getting a fuel sensor is there in the car. That is an IoT, and that gives you a machine that finds out what to do when the fuel goes low. What to do? We have given indication. That machine has to do the analysis. What the machine does, it gets the readings of the temperature of the sensor. Okay, where the who is finding out if it is the car is based on the temperature or it based on the fuel, who is going to find out whether fuel is less, whether temperature is too hot and some repair action has to be taken. That fuel information from sensor is taken by IoT and given to a machine, and that machine finds out what next action has to be done. And that is why on my right hand side you are saying the thing is finding out the attribute and then giving the electrical stimuli, and the electrical stimuli action is being taken by this machine. Okay, so that is how the MTM and IoT has to be looked at. Looked at. Okay, right now on my right hand side you are seeing a lot of rounds. Each one of them is a network. Okay, now we have discussed about the sensor network. The sensors are there. Okay, for example, now the tsunami is there in the sea. Tsunami sensor network is there. The tsunami sensors we are putting in a buoy. They're called the floats. They're floating on the sea. In between the sensors and the floats, we have to have the network connection. The network connection has to be necessarily wireless. What type of wireless networks are there? There are so many different type of networks are there. There is a wireless Zigbee networks are there, Wi-Fi networks are there, wireless pico area networks are there, WPAN is there. If the short range means is there, Bluetooth network is there. Now these sensors are getting those information collected through the sync they are giving to the say shore. The shore it has given to connected to the internet. Okay, this is how network of network. There are so many networks which has to be connected through internet. So IoT is the combination of network of network. There may be individual network. There may be individual network can be connected together. There will be separate network for transport, separate network for energy, separate network for other. All of them may be connected together. They may form one network that is called the Internet of Things. Maybe it may be one network, it may be more than one network. So now in your visualization, you have to imagine that there will be one simple network door opening, one sensor, one actuator, which takes action for the sensor information and then opens the door. That's a very simple network. There may be a network, they take a case of a police network where surveillance cameras are there. Hundreds of cameras are connected by wireless or by wired. They are connected in a group, and then they forms a network of network, and then given it to a control center where people can monitor and find out the control the movements of the vehicles. So that is how it looks at it. Now your visualization has to start from simple sensor, getting connected to network, small network, group of such a network, forming a network of network, and that is how it goes to Internet of Things. It may be a combination of machine-to-machine communication. It may be a combination of device-to-device communication, and both. Okay. Now we have to see Internet things, how evolution is taking place. Okay. So what is the evolution? Now device finds out the environmental information, converts them into electrical impulse, and they are connected. That means sensors are source sensors, sync sensors. They are all connected as a network. They get the information, convert them into electrical. Okay. Then they have to be collected, group them, find out whether accuracy, compute them, then they have to store. And then after storing, we have to get an application. A lot of network, very good data. This is a complex analysis. And then we have to find out what is the value of everything. There is an open access of data. Okay. So much of information, and that becomes a big data. They come from everywhere, right from thermal sensors. Then they're finding out the health information system. Lot of information are coming. That means it is not only Internet of Things. It is not all. It is information, Internet of everything. That is, it boils down to Internet of everything. Okay. Now there is a simple max. I will tell you what is IoT. Okay. Start from right. As we write Urdu, you have to remember this way. Whenever you write Urdu, we start right from left to go. That is a system. Like that here, right hand side, smart objects, sensors, which has been built into the electronics. They sense the environment, intelligence, convert them, compute them, find out the value. Now that is an operational technology. The smart objects, we have an operational technology built over that has been transmitted to a distant end. We require an information technology. Smart objects plus operational technology plus information technology is comprising of IoT network. So this is the formula for IoT network in a simple language. For this concept is very useful. This particular slide, if you want to teach to your students, so that is how you can just make a note of that. Now, Internet of Thing and everything, the boundary, this is a very good slide. You can see, you see now Internet of Thing, what I have discussed. Okay, all objects, they may be electronic, they are connected, they are tethered. You all of you know doing tethering in your mobile phone. What is the meaning of tethering? Now I have internet on my mobile phone and I am doing tethering. That means it is just like tethering means that buffaloes are there in villages. People take a rope and then tie on to a pole. That is called tethering. That means the buffalo is the internet. You tie to a pole. That means that is your laptop. That internet is now flowing to the pole and then to the laptop, and then you start working. If you take your mobile as a cow and the rope is the tethering and the anchor is your laptop. So that is the meaning of tethering. Now, when you do the tethering, the IP device, it is able to getting connected, and it is an addressable device. And it may be a closed network, it may be an open network. Okay. Now, unconnected and non-IP addressable. Non-IP addressable, that means it is a sensor network that also can be connected to Internet of Things. That is what you have to see here. And there may be non-electronic like desk chair, unconnected electronic devices, coffee maker, vending machine, and all. They can also be connected and they can also be tagged. So one day you will find that everything can be connected to Internet of Things. Today we study Internet of Things. Tomorrow it may be Internet of everything. Okay. Now you have to see the architecture. Now, having seen the fundamentals of Internet of Things, and then we made an opening for you. Now we have to see the Internet of Architecture. Basic architecture is communication, agent, controller, actuator, and then sensor. So now I already told you sensor. There are so many different types of sensor. Sensor itself is a separate subject, and there are a lot of whenever you start studying the sensors, the power problem is one of the problem, and programming is another problem. All these things you have to try to address. Now I will discuss one by one. I have a separate slide for each one of them. See, actually, when sensor finds out the information and converts them into electrical signal, it has to be communicated outside. Okay, so it may be wired or it may be wireless. Mostly sensor networks are wireless in the sense because I cannot use the word mostly because lift you say it is wired, air conditioned room sensor you see it is wired, but wireless sensors number of applications for gas may be more because the number of devices getting connected to the internet is now outsmarting the population density of the world. So that is why we can say now Internet of Things, number of things are more, which is getting connected to the wireless. So when I say there are short haul and then long haul, Wi-Fi, Bluetooth, and then near field communication is there. Of course, I'm going to discuss this in the MTM tomorrow. So I'll just make a mention here and then go. Tomorrow I'll make an elaborate discussion on this. It's a communication layer. 3G, 4G is there, now 5G is coming. Okay, narrowband IoT is there, Sigfox is there, low power radio, that is a protocol device is there. Okay, we have TCP, transfer control protocol, and then UDP protocol, IP, HTTP, and mainly here what we have to see is the COAP, constrained application protocol. I'm going to discuss this. What is the constrained application? Okay, when you say TCP, every time you send the packet and then find out the packet received correct or not. If not received, then you say send back. Then again, retransmission is taking place. Okay. And in the case of sensor network and Internet of Things, the device is so small. The communication network is, that is, let us say Bluetooth, near field communication, the bandwidth is so small, very less bandwidth. Then how to communicate? You cannot do every time, then whether I sent is correct or not. You cannot go on repeating. The moment you send in one go, it has to go, and it should go very correctly. Therefore, the HTTP, TCP, IP, UDP cannot be used in this communication protocols in the IoT devices, and therefore we have to go in for different type of protocol. One of them is the constrained application protocol. We will see deeper into that. Okay. So now, whenever you do the research on IoT architecture, you have to decide whether you are going to do any short haul, whether you are going to do the long haul, and what is the type of protocol you are going to use. And if it is an electrical engineering stream, if it is say smart grid sort of thing, so there it is latency is more critical because it is going to handle the generation, transmission, and then distribution type of things. That also has to be taken into criteria. Now, coming to the agent, what is the agent here? See, normally sensor network, if you start discussing, we don't use the component here as a agent. We will both put together in the controller itself. Now, in here, the agent is discussed in IoT architecture. It is nothing but an embedded program. Okay, it is not only bridging the say from the sensors and the controller and the communication. Okay, controller and the cloud. Okay, now what is the bridging? What is the agent is going to do? Okay, that is the point. Now, sensor information, suppose you connect a door alarm, okay, door opening alarm, a simple thing, lab model. There is a sensor. So the laser light is going from one side to another side, then the door opens, it gets cut. The resistor value on the that is a resistor is varying. The variation is interpreted in the program. If the resistor value is more than this thing, the door is open, or else the door is still closed. But the resistor value goes beyond the critical level. Controller finds out the door value, that is resistor value, is more. That means who will interpret the value? So when the value of the resistance is, let us say, more than 100 ohm, the door is opened and the laser beam is cut. Because of that, resistor value is changing. The program embedded in the agent finds out the value, convert them into a message, and then send it to the client. Let us say it has to be sent it to an SMS, then it has to be connected to a mobile cloud. The mobile cloud SMS format has to be changed, and then the protocol has to be changed, and it should be sent on a mobile network. This is called bridging. This is called bridging. So there may be a mobile cloud, or there may be your own data cloud. Anything may be there. Okay, so that has to be bridged. So the controller and communication, this has to be bridged, and that is why the agent does the job. It is deciding what is the type of data to be sent. Say, for example, say now zeros and ones only will be there in the controller program. Okay, and that has to be sent to communication. Okay, it has to be formatted into a packet. If it is a mobile communication, the formatting of the packet is different. Okay, then it has to be changed accordingly. So it has to be the agent is deciding what data has to be sent, and then only when the memory network is ready, the SMS can be sent. That also when and what data has to be sent. For that, intelligent algorithms have to be built in, and that is the concept of agent. Now, controller. All of you know these microcontroller programming. We're all very familiar with that. And then this nothing but a microcontroller. The sensor is connected to the microcontroller. Here, the complexity you have to appreciate. Microcontroller memory is very less. There is no hard disk to store the information. The that is the random access memory is very less, flash memory. Then your normal operating systems will not work on that. Therefore, the controller design is specific to the application. If the door opening program is different, if it is tsunami detection system is different, disaster management system it is different. So each system, each application is different. Accordingly, the software is loaded, that is built on this. It is write once and read many times on the controller. This another problem is now, for example, I tell you now, if the tsunami sensors are now floating on the sea, if there is a program update has to be done, how will you do that? It's very complex. You cannot go to the sea and then locate it. We do not know. Well, we know only the lat-long, and we will not be able to locate and then go there. And by the time it will not be there in that place, it would have moved some other place. So how to do the software upgradation? So like that, the battery power has gone. What to do? These are all the complex situation. So the microcontroller program is very complex in an IoT architecture because it integrates the wireless sensor networks into the networks. Okay, so that is how the controller programming is very different, and then we have to choose what type of controller is. Another area of research in this microcontroller is the power consumption, battery life, and then how long the battery is going to. Also, the design of the application is very specific to the life cycle of the particular application. And now coming back to the sensors, all of you know from the wireless sensor, I will repeat it now. There are a lot of sensors are there, and they are very tiny sensors, and their sensors are very specific to the data, very specific to the particular application, and that has to be selected, and that will find out the monitoring of the environment, convert that event, that is, let us say, heat event, pressure event, touch event, okay, smoke event, whatever it is. Okay, they will be getting those information and then changing them into a meaningful information and then transporting them on the wireless networks to the sync network, which is going to collect and then process it, find out where it has to be sent. It has to be terminated in the sensor network itself, no issue. Normally, every IoT architecture, it has to be transported to the internet. Internet is IP addressable. Sensor is non-IP. Sensor is data centric. That is, internet is IP centric. Now, how the data centric can go on IP centric? Therefore, there must be a device that is capable of converting the data centric into IP centric, and there the source node is data centric, sync node which collects that information, pre-process it, and then does the computation, which where the IP centric capabilities are built in. Therefore, the sync node takes this data centric information, puts that IP centric value, and then pushes to the network, wherein it goes to the internet, and then based on the IP, it can be sent to anywhere across the world. This is the point where the gateway concept is coming. Normally, the concept of gateway is that when you are dealing with two dissimilar network, the gateway comes. Okay, that is a very important point. We have to appreciate that. That means a gateway is, you have to very easily understand two dissimilar network. That means road network is there. I'm going in a call taxi. Now I want to go to pick up a train. That means it is a different network. Then there is a gateway is the railway station. You have to go to the airport from the taxi. Taxi is the road network, and the airport is the air network. Then there is a gateway is the airport. Like that, sensor network is only connected with the sensor where data-centric informations are coming. The data-centric information with what? Forest sensor is only dealing with the temperature. It is data. It deals with only data. Okay. Suppose now two sensors, one is finding out temperature, another finding out pressure. Both of them are sitting together. They will not talk. They will talk to each other, but find out who are you? Who are you? I am having temperature information. No, you are not my man. Then temperature sensor finds out another sensor nearby and then say, hello, what is your value? I am having temperature information. Okay, we both together take this and then send it to the sink. Whereas the pressure information sensor finds out the another node who is also similar to that. That is how the data-centric information moves from one place to another place. Okay, and then actuators. Actuators is only thing is here. Augmented, there are two concepts, augmented intelligence and then augmented behavior. These actuators, I am going to discuss that. Augmented, what is augmented intelligence and then augmented behavior. Here actuators are nothing but their behavior, augmented behavior. That means somebody is touching me whom I don't want to touch. Okay, that means touch information has come to me. My brain finds out, no, when somebody touches you, they are not an appropriate person. You give them a slap. This is called an actuator. If the same brain, when somebody touches, says that this is your child, you hug them. Then the brain then tells you that so you hug them. That means actuator does two different things for two different events, depending upon the touch sensors. Okay, the touch sensor finds out the value and then do the processing and then gives information to the actuator. What actually you have to do? What is the behavior you have to do for this particular sensing activity? So that is the meaning of the actuator. Okay, the actuators are pressing, going to the airport, and the moment you go inside, pressure sensor, you are pressing by your foot, and then the door opens. When you go and then presses the button, the lift door opens. That is the pressure sensor. So this is the actuation. One is the sensor is the pressure, and then actuation is the opening of the door. Then fire happenings, smoke sensor detects, and then it gives information to the alarm bell. So this is the actuator. Therefore, IoT architecture has modules, communication, then you have the agent, then you have the controller, then the actuator and the sensor. The communication is mostly we'll discuss about the wireless communication. Wireless communication, we have that transmitter and then receiver. Wireless communication. Okay, we have a device which is capable of doing both. Now, in the composite structure, how they are connected? The controller sensor is connected, and then actuator is connected. Then the controller on the other side is the agent, and then there is a communication. Now the sensor senses something, gives to the converts them to electrical signal, gives to the controller. The controller program reads the program and then finds out what actually has to be done, and then that information is given to the agent. That agent now finds out, okay, that information is there. To whom it has to be sent? Whether it is IP, okay, IP means which direction, where is the gateway to be connected. All these things are known to the agent. That the agent gives to the communication device. Communication gives to transmit that to another communication device, and then it goes to the gateway. And then gateway, you have seen the earlier slides. It is given to the laptop. It was given to the mobile as a SMS message, or it has given to some other device, say as a mail message to a server. So that is how the composite architecture of IoT is now being made up. Okay. Now, next thing is a reference model. This is a little important because many of us are communicating. So basic thing is an ISO reference model. 7 layers are there. Here certain layers are combined now. Here you have device from bottom you go. There is a device layer, network layer, and service support layers, and then application layer is there. What we have to very really understand here is, so it may be from gateway to gateway. I already told you when you are going from one network to another network and they are dissimilar, then you have to use a gateway. Okay. And the device capabilities, that means a sensor network straight away takes from the device layer environmental information and then convert to electrical. Now that has to be then transported and we require a network. Okay. And then what are the support capabilities? Service support. What is the different type of service support? Service support, that means depending upon the application, whether it has to be actuated, that is one type of support. Straight away, when tsunami coming means you cannot take it to the server and then send SMS after 2 days, sudden. And there are it is only for statistical information. Then you take it and then pre-process and give it to after some time. Okay, whether it is critical or non-critical, that is a type of support. Okay, very specific support, that means hospital information. When you are doing the surgery online, that information very critical, latency is very less. And if it is a small grid network, when there is a snapping of 220 kV line, and then instantaneously within 2-3 milliseconds, that information has to go. That is a specific support. And then IoT application, that means nowadays many of you are well aware that Arduino is there, Raspberry Pi is there, Python is there. These are all software development areas, that is program on which you develop IoT application, which is sitting on the service support and then IP, that is application support layers. Okay, so your basic reference architecture model should have basic support. What are that? One is application support, then there is service support. Okay, and then there's a network capabilities. What is the network capabilities? That means whether it is Wi-Fi network, whether it is a Bluetooth network, it's a LoRa network, I must be able to support. And the packetization has to be done accordingly. Then transport capability. That means I want no latency. I want yes, okay, there can be some latency in terms of millisecond. Then you have to choose network according to that. So that is the probability of transport layer. Okay, that is also taking care of the gateway capabilities. Okay, the network and then transport layer. You would have heard of layer 2 network and then layer 3 network. Layer 3 network straight away it is going to the network ring. We have only one router which is capable of doing both layer 2 and layer 3. Okay, like that the network layer capabilities are taken care of. Now there is another thing is a cross layer management capabilities. So this is another very important area for people in the faculty. They are more interested in doing research. And in the Internet of Things, cross-layer capabilities, management capabilities, very good resource area, and you can many of you can start thinking on these cross-layer management capabilities. What is cross-layer management? Okay, now device layer is there, network layer is there, service support layer is there. If you take a ISO layer, 7 layers are there, physical, then you that this one different type of layers are there. Starting from application, then network, transport layer, network layer, data link layer, then physical layer. Okay, so the design of the ISO layer is that each layer is compared by itself. The data flow has to go from one layer to another layer, and then the plugins has to be designed based on the layer protocols. That means the layers are very compact. The data flow will be from say, let us say from bottom to top or top to bottom, crossing one layer to another layer. But there are certain situation now here, as you see, there may not be any necessity for data link layer. Straight away can go to network layer. You are going to see in the days to come. You say Zigbee is there. Zigbee, we are not using 7 layers. Certain layers are removed, and they are introducing the Zigbee layer. That means you will have only 4 or 5 layers in that. That means they are skipping some layers, and those layer capabilities are built in on this. Okay. Now, in case that you don't require a transport, and straight away the device can give it to the network. Okay. Can it be done? Yes. This is called cross layer. I'll give an example now. So now there is a grandfather. He has got a grandson. In between, this grandson has got a father, and then he has got a grandfather. Suppose now if the grandson wants to marry somebody. As per the protocol, what he has to do, grandson, that's a physical layer. Then next is another layer, son, that is father, and then it goes to grandfather. Grandfather gives approval, and then this grandson gets married. Okay. Nowadays, what happens? This fellow loves somebody, and then he wants to skip a certain protocol. He does not want to speak to his father. He straight away goes to his grandfather and then gets his permission. This is called cross-layer management. He skips the layer of his father because he feels that that is not required at this point. Straight away, he says sure that he will get permission from his grandfather. This is called cross-layer management. In our basic reference of IoT reference model, there are situations. Say, for example, I tell you here, you have a common database. The devices will give all information to the common database, and the different layers will straightaway take the information from the common database. That means you can skip those layers and then give to the database, and the database will manage. If necessary, it will use the network capability. Otherwise, it will skip and then go straight away to next layer. Therefore, the duration, that the delay can be reduced. Like the signaling, you can develop a straight signaling pipe, and then the signaling pipe you can skip some of the layers, and that signaling can be taken to another layer. So like that, cross-layer management has got different lot of research papers on that. Still, this is a very good area for you to do the research. Like that, cross-layer security. Security, we are going to discuss about security, and then in that, similarly, the concept of cross-layer can be applied to security also. Okay. Now, that's why I'm going a little deeper into the Internet of Things architecture. On my left, you are taking a vertical architecture. I'm taking one unit. You see in the bottom on my left hand side, the device is a sensor device A connected to the local network, and it doesn't go out to a normal IP-centric network. Therefore, gateway is required. Then communication is given, wireline and wireless network. Then over that application is there. Then device finds out some changes in the environment, and that is sent an electrical impulse. That application reads that impulse and then takes action accordingly. So this is a simple network. Take for example door opening, or this lift opening, or the door opening in the airport, or something like that. This is one. Okay. Now there are so many such devices, so many such networks are connected. Now come back to my right hand side. This is a horizontal. Okay, based on the common layer. Now, like this, there are several such applications, 1 to n application, 1 to application n. Now 3 are shown. There can be many applications. All of them connected to a common service layer. They are connected to a different type of network, and there is a common service layer. Okay, connected to there is a common service layer which is coming in between application and the network. This network commonly connected. Now you see on my left hand, that is in this bottom, things are there in the center. Things shown just like eggs, things. That is, things means they are device. That is, there is sensors. The sensors are the sensor taking the information, converting to electrical information, then gives to the device. The device connected to the local network. Local network connected to the gateway. Gateway connected to the communication network. Communication network is served by service layer, and then it is connected to the application. So their IP layer, the entire communication network is an IP layer. This local network, what is given is a non-IP layer. You can take that, and then on just the other side, you can see device that may be a machine, maybe a robot. It is a machine-to-machine communication, connected to communication network, and then they are going to a common service layer. The device on the left-hand side, things can take the information and then can give to another device on the right-hand side. It's also possible. This side is the thing, that side is the machine. Or it may be a device to device, machine to machine. Everything is possible. So in the Internet of Things architecture, there may be a pipe only one vertical. There may be more than one vertical having a horizontal cluster. There may be more n number of clusters are there, and that has to be handled. There comes the complexity of the IoT network. Okay, Internet of Things network. Okay, now Here, this is more for research, for concept only I brought it here. There is one concept called Steve Deering's hourglass model for IP communication. The hourglass you see on my left hand side, top email, phone, SMTP, HTTP, TCP, UDP protocols are there, applications and the transport layers are there. Then IP, that is the network layer is there. Bottom you have a protocols, and the physical layer is there, copper, fiber, radio. Okay. Then Ethernet. Okay, that is the data link. They see that is a physical layer is getting connected to data link, the network, then the transport layer, then going to the application layer. Okay, that means the model, hourglass model, what it says, if there is a common waste of the hourglass, then all application can work over all physical networking technology. If there is a common waste, what is the meaning of common waste? I give you a concept. Okay. Now, you take the case of a belt for a human being. A gents, we are wearing belt. The pant I'm wearing and then shirt I'm wearing. Always you find I use only one belt and I have different type of pants and different type of shirts. That means any type of pant, any type of shirt, if I have a one belt, it will work. I can do. That means all applications can work if there is a common waste called IP over any networking technologies. That means everything can be on IP, everything is over IP, and IP is over everything. This is called common waste concept. That is Steve Deering's hourglass model for IP communication. That means IP communication is possible if you have a common waste. That is IP. In this case, in the Internet of Things, we have an IP network. IP Internet is the Internet protocol is there. The sensors, devices, machines, which is capable of doing sensing and management, they can be connected to anything across the world, provided there is a common waste called IP. Okay. Over this, okay, on this IP, I can even have HTTP protocol, COAP, XML, any large class of IoT applications. Okay, they can work as a popular transport mechanisms. So that is the concept here. This can give you opening to many of the things across the Internet of Things in the world. Okay, right. Now coming to Internet of Things technologies, what are the different connectivity options are there? Wired option is there, wireless option is there. In the wireless option, you have a wired option, you have anything fiber, copper, Ethernet, and then wireless pico area network, wireless mesh network, wireless local area network, wireless wide area network. Wide area network, 2G, 3G, and 4G. Wireless LAN network, 11.8 BCD, and then you have they are using free spectrum, 2.4 gigahertz. Mesh network CB there. Okay, wireless Z-Wave is there. There are so many network protocols are there. Now, I just to give you an idea here, communication technologies, Internet of Things, there are two concepts. One is wired and wireless. Wired we have nowadays without fiber, nothing is there. There are different, so many type of technologies are there. Ethernet and fiber, the most common, and then wireless, Bluetooth, Wi-Fi, Zigbee, and 802 series are there, and then mobile networks is there. Okay, mobile network and 5G network is now more going have a very good impact on IoT, and that is why you have a session in the afternoon. Now I will go deeper into that tomorrow in the session MPM. I'm going to discuss this how they are going to help in MPM communication. Because of this introductory session, I will stop here and then go to the next one. Okay. Now, constrained application protocol, I told you, is a IP waste is very small. That means communication bandwidth small. The problem of latency, speed problem, everything there is a problem. So I cannot use just like a HTTP on a sensor network. Hypertext transfer protocol, I cannot make use of that. So I have to go in for different type of protocol. So let us say COAP, and things like that. Okay, right. Now, what are the data aggregation standards? So the data I'm collecting, now you should not think that there is only 1 kilobyte, 2 kilobyte like that. The sensors may collect a few bytes of information. You take a case of 1,000 acres of forest land, and there are 1 million sensors are put. Okay, in Australia, fire they could not control. Okay, in spite of this network, because the network has not been maintained properly. Okay, now let us say 1 million sensor, each of them having some few bytes of information. Then you can find the total collected data maybe in terms of terabytes. Then how to aggregate them? So aggregation is one of the very important aspect here. Now, only here that now million tons sensors are there. All of them are going to handle only the temperature information, and temperature going to be critical. Critical means if it is only 35 degrees centigrade, the fire will burn. Okay, the forest. Now there are group of sensors are there. We form them into clusters. Each cluster gets the temperature information. Temperature information will be varying. A cluster of 100 sensors bringing different type of temperature information, 30 degree, 31, 32, 33. They will be averaged. They will be aggregated. They will brought to the cluster. The cluster will get that information. Like that, 100 cluster will be there. All those 100 cluster will be combined in one place, and that will be aggregated. Okay, and that aggregation will be extracted, transported, and then loaded. So this is the concept of data aggregation. Now, if you see this one, the data aggregation standard, you'll be able to appreciate. That means sensor gets unprocessed, then they are aggregated. After aggregation, it comes to the sync node, which is the nodal agency. After all group of clusters, they are aggregated, then they are brought. Now that has to be extracted. Extracted. What do you mean by extraction? That means the error has to be discarded. Optimization has to be done. Suppose wrong data has to be discarded. Right data has to be taken. And that is called extraction. That data has to be transformed. Transformed means it has to be taken on a gateway and then to be transported. That means it is data centric in the wireless sensor. When it goes to the gateway, it is IP centric. The format is different. It is to be transformed. After extraction, it has to be transformed. Transformed, that means these terabytes of data transformed in an IP centric network and then received in a server. Then that server it is loaded. The loaded means then there is a SQL database. It's a big data. There are different sets of data sets are coming. You see, for example, it is probably now different states. The information regarding as a coronavirus has come. Let us say now it is a central government is now processing the data. Data set 1 has got the name Tom. ID of the state. Data set 2 is there. A, Z, T, X, and all CA. Now we have to put the query based on the ID, extract the query data, name, and then state has to be correlated. That's query. Then SQL query comes. How much information, temperature information received in a different state, how many of them are suspected, okay, for the virus, that is classified, and then using the analytical tool is given to the visualization. Let us say now Arogya Setu visualization information is now given. Okay, that is how the data aggregation is done in this IoT. Right, now how it is implemented? Okay, it is again the same information. Let us say now sensor. Now sensor taking the information, then creating a data, acquires the information, data acquisition, network it is transmission using the wireless information network, okay, or maybe due to applications they're communicated, then it is aggregated, okay, then it is analyzed. Here you are seeing augmented intelligence and then augmented behavior. So what is augmented intelligence and then what is augmented behavior? So there are two things. One is there is a data, okay, and then the data has to be analyzed, okay. Now I tell you now, the temperature information has come. The temperature information is now available in my database. Group of information depending on the lat plan, latitude and longitude. Under latitude and latitude location is there on the forest, and then ranging from 33 to 40 degrees Celsius temperature information is there. Now you apply your intelligence, find out which is a burning situation. Let us say 40 degrees Celsius. 40 degree is correlated to Latland, and the Latland is now actually converted into the location. In that location, fire is now taking place. This is called intelligence. The raw data analyzed, use the analytics, and then the information we use the push notification. Push notification means it is given to the authority who is looking for that information. That is called pushing information. The forest range officer is looking for information. I am pushing to him. He looks okay. Fire is taking place in the location. He is not worried about whether 33, 40, all these things, how it is analyzed and all. He only knows latitude, longitude. This is the location. Fire is already there. What action is to be taken? That means intelligence finds out what is to be done for this. Augmented behavior is what actually is done. Okay, it is as good as that. Okay, a child is touching me. The touch information goes to me. Is augmented intelligence. It says it is child. Okay, it's a good touch. Okay, what is the behavior? Okay, that is the action. Okay, that is the action. That is called augmented behavior. So we have to very clearly understand what is augmented intelligence and then what is the augmented behavior. The IoT implementation, starting from sensor, the network, how it is getting integrated, how you are building up the augmented intelligence, and then how you are getting the augmented behavior out of that. Now let us see how a IoT network can be built up. Okay. Now sensor is there. Okay. It is connected to the Zigbee chip board. The sensor gets the information, Zigbee collects it, transmits to coordination layer, that is the Wi-Fi GPRS, that is module, that is the network, is now getting connected to firewall, and then go to cloud-based services, and then it is distributed to, that is augmented, for what augmented behavior here, whether it has to go to web application, whether it has to go to iPad application, whether it has to go to Android application. So this is how the network has to be built up. Overall, holistic view that sensor layer, coordinating layer, and then supervision layer, and that is how the network is built up. Okay, how the future networks will be there? See, started from 2014, it was not like that, as today. Today, more number of the people, the number of devices connected is outnumbering the census population. That is the total population of the country. That is where we are now in 2002. And then now we have a network for anytime connection, any place connection, and anything connection. It may be indoor or outdoor. It may be human between PC. It may be human to human. It may be human to thing. It may be thing to thing. And it may be anytime. And that is how the future network is going to be. Now, I need not explain this slide because now services bounty. You cannot count. I cannot explain. Only you can see one sector, devices, location, application, group, service sectors are so many sectors are there. Okay. One sector, if you take building sector on my left hand side, building sector, then you have industrial, then process cleaning up, and that there are so many activities are there. So opportunities are bounty. Area in which IoT has not gone inside, nothing is left. Everywhere it is there. Okay. Point. See, you take retail on my right hand side, specialty, hospital, and stores. So supermarket, and then goes science, vending machine, cash registers, tax, and POS terminal. So much services are there, and then everywhere you have an opportunity. That is what we have to appreciate here. Now, research on IoT and then related market. Now you have to see the IoT. See, for every say landline network or mobile network you take. There is an authority who controls. If something happens on my mobile, you can ask my vendor whether BSNL or this one. In IoT, there is no central authority. And then you take a mobile phone, there is a vendor who answers this. Whereas in case of IoT, small devices, umpteen number of millions of vendors are there. There is no control. Service providers. You tap a door, there is somebody who says, I will provide you the network. You go to pawn shop, there is a vendor who provided a surveillance camera. There is another meat shop, there is another vendor who provided another sensor. Okay. Now there are the okay. You are not hearing me. Hello? Hello, all of you
We can
hearing
hear
me?
you, sir.
Audio is clear, sir. Audio
Yes,
is
sir.
clear. There was some disturbance in the network. This was in the participant's mic, sir. That's why you are muted.
No problem. No.
Please
Are you
continue.
okay? My speech is
Yeah,
okay.
fine, sir. Absolutely fine,
All
sir.
of
No
you are
problem.
happy. All of you are happy.
Yes,
Good.
sir. Yes, sir. Fine, sir. Audio is fine, sir.
Okay. And then now
Sir.
challenges.
Sir, the time is 1 o'clock, sir.
Now it is. Can you extend for another a few minutes, 5 or 10 minutes?
Yeah, no problem,
Or
sir.
you want me to close? What the
Yes,
participants are telling?
Sir, you
Participants are-
Continue, sir.
Continue, sir.
Yeah, you give me another 10-15 minutes, I will complete. At the end, I have one small video, 5 minutes, I will play and then summarize. Okay.
Understood,
Challenges.
sir.
Yes, sir.
There is a network
Yes, sir,
challenges.
you can
scalability.
continue.
Sir, regarding participants,
Okay.
like this timing and all, we will take care. So in case if you want to tell something, you please post in the chat. Don't disturb the session. Sir, you please proceed, sir.
Okay. And then there are key IoT concerns are there. Security is the concern, data collection and analysis is a concern, and then connectivity is the concern, hardware integration is the concern. So these are all the concerns you have to address. Whenever you start teaching, also it's not really the subject, and the concerns more. Okay, and all devices are not computer. Okay, they pose a lot of problems because the network perimeter is not designed, capturing vulnerability is there. And then there is a lack of device management software is there. Attack, data breaches and attack, because it is not IP centric, it is data centric. The attack is too much and then very difficult to find out. And then the security is now building up. It's a long way to go. Okay, the network is getting compromised. So, and if you see the IoT is very good. There is a very good automation and control, and then the information of big data is there. The communication is becoming more and more complex, and we are able to monitor, and then overall quality of life is improved. Then the complexity is no high-level international standards. Standards are building up. It is coming, and still there is a lot of scope. A lot of failures are there in the operation because tiny sensors which are not standardized, sometimes standardized, something not standardized, and privacy of security is compromised. Very difficult because sensitive data is in the wild, safety is in the question, and the social interaction is now everything is now device. The social interaction is becoming very less, and then going to the research. Okay, real-time computing is one area. Machine learning is one area, artificial intelligence is another area. Okay, signal processing, big data and cloud, integrating IoT, they're all very good areas for integration. Now coming to the summarization, okay, on my side, a green arrow is there. Previously, a nurse will take a X-ray and coming to the doctor, bring it to the doctor, and then say, what is the disease? And the doctor will do the disorder. Now coming to B, IoT, the X-ray is taken and sent it onto the network, and it is integrated and aggregated. Augmented intelligence is coming into the picture, and the augmented behavior doctor is interpreting, and the medicine is prescribed online, and then the patient is getting cured. Okay, so this is how the A was previously. Today the B circle. It is a simple circle, and where it is getting completed, and sensors are creating getting the information, creating a network, communicating, getting integrated, and it getting aggregated. Augmented intelligence is coming, and analysis is done. Augmented behavior is acting on that, and that is how Internet of Things is getting a complete. And what I discussed is it's only a tip of iceberg, and then more are there. And to conclude, and you find that more connected devices than the people is there is somewhere in 2005, 6 onwards. Now it is now multiple. More connected devices per person is 6.58. Okay, connected devices is 50 billion. Now a curve here, you find on my right hand side a curve here, a sensor is there. He is now the person who has got a herd of thousands of cows doing a very good business by connecting all the cows in the network. And he knows how what is the age of the cow, when the cow will start breeding, how much it will yield, what is the health of the cow, how much grazing is to be done. Everything is network. At what time it has to go out, and what time it has to come. When it enters, automatically the gate opens. The milk is how much milk is now taken out of the cow. All these things are network, and that is the simplicity of the IoT. Okay, and threats and opportunity is I can say one point. If it is misunderstood and misconfigured, there is a risk. If it is understood and configured, it is good, and that is an opportunity we have. And thank you for all of you. You gave me a good time, and that is a thoughtful gift of all. Now I will put this small video, live simplified with the connected device. It's only run for 5 minutes. With that, I will end the session. You can listen to that, and then I know playing.
Sir, I think we can upload this video, sir. It is breaking more.
No, finished. It is getting finished.
Okay, okay, sir. Okay, sir. Sir, anyhow, you can send to us.
Oh, over.
We'll upload again, sir.
Okay. Okay.
Thank you, sir.
1 minute. 1 minute. I will just summarize. 1 minute.
Okay, sir. Okay, no problem, sir.
Hello. I'll just summarize 1 to 3 few minutes. So we have so far seen about the sensor networks, that is Internet of Things, starting from what is the definition and meaning of a sensor, and how sensor is getting connected to more than one sensor and then forming a network. And then we have seen then how the sensors and devices are different from machine to machine communication, and then how machine to machine communication forms a subset of Internet of Things. And then definition for Internet of Things, we have seen that is the thing is devices which has got the electronics and then program which is capable of getting connected to the network, and then passing the environmental or whatever information, sensor information to outside the world, and that is the Internet. We have also seen what is the network of network. Network of networks having say Wi-Fi, Bluetooth, and different type of network. What are the protocols? And then we have seen what are the limitation of the network in the, because they are very tiny. And then we have seen the architecture. That means communication, agent, control, and then sensor, and then actuators. And we have seen what is the purpose of the actuator. We have seen how one network can be built up, and then how the augmented behavior, intelligence, and then augmented behavior comes into the picture, and then how the one network can be built up using sensor. And then we have seen a vertical pipe and then horizontal, more than one network is getting connected. And then how machine to machine communication is taking place, and what are the difference between these things. So and then what are the potential pros and cons of the network, and then we have seen what are the research areas in this particular network. Okay, that is Vijay. Thank you very much for all the people who are patiently listening to me. And I'm late by some 5 minutes. Thank you very much. Sorry for the late closure.
No problem, sir. No problem, sir. It's okay, sir. We'll manage the time, sir. No problem, sir. Arul, sir. Arul,
Hello,
sir.
Madi sir. Yes, sir.
Sir,
Yes,
you want
sir.
to, please proceed, sir.
Yes, sir. Yes, sir. Yes, sir. Good afternoon, everyone. So this is Dr. Arul, FDP coordinator. I hope you enjoyed the first session. So thank you, Santhana sir. A nice presentation, a nice informative session. So in between we face some technical issues, some audio issues. So that we will take care in the upcoming sessions. So I have to share some of the things. So all the session presentation PPTs, whatever the materials, we will upload in the cloud. So either evening, definitely whenever we will get it from the experts, we will upload in the cloud. Mostly the day evening itself, we will get it in the cloud. You will get the access in the cloud. You don't worry about that. So most of the chat, I have seen that most of them you are asking about the, sir, share the PPT, share the PPT. You don't worry. We will upload all the materials immediately in the cloud. You get access from the cloud. So another one thing is, already I sent the cloud link access to through your mail. One more thing.
They mind or not? Arul sir, again you have to unmute, sir. Some disturbance in the audio. Hello? Arul sir?
Sir, it's okay. Ah, yes.
Yeah, yes, sir. Fine, sir. Fine.
Okay. Sir, and one more thing. So in the chat box regarding thing, I have seen that regarding the exam. So regarding the exam and one more thing regarding the certificate also. So I have to mention one more important thing. So 80% of attendance is mandatory. So once again, it is very clear and it is very strict also. Total 14 session. So you have to attend a minimum 11 session. Then only you will get the certificate. At the end of the session, you will get the one exam. So exam, all the things are, whatever the sessions are going on, from that only we will take the questions. Okay. So it will be, we will give that details, and the last, before that 13th exam, before the Thursday evening, we will discuss about how the exam we will conduct, everything we will discuss the Thursday. That I will send through the mail also. You don't worry about that. But your attendance is very much mandatory because we are conducting through online. All the attendance we will take it from the log history only. So whenever you are login, whenever you are log out, all the information will be recorded. So it is online. So the information directly goes to the AICTE site also. So I will not do anything. So I cannot do anything also. So better you attend minimum 12 session or 11 session. Then only you will keep maintain the 80% attendance. So in between you don't unmute. So whatever you have any doubts, you post in the chat. The speaker will rectify end of the session or the time being also. You don't worry. So now it is almost 1:15. Now we will start our Madhi sir. We will start our next session 15.
Right. Sir, it is 1:18. Shall we start by 2:20, sir? Is it okay?
Okay, no problem. Okay, no problem. 2:20. So before
Yes,
15 minutes, the session link will start.
Yes, sir. Yes, sir. Fine.
On the session, the link will be enabled before 15 minutes.
Sir, and regarding the video recording also, sir, you tell now itself, sir. People are again.
Yes, sir. Sir, we will not send the video recordings directly to you. Only the PPTs only we will send to you. So video recording we will send to the AICTE. So AICTE they will upload in that their website. Because already I discussed with the AICTE. So they told don't send the videos, recording videos directly to the participants. Okay. We will send all the PPTs, all our materials, but the video you will get it access from the AICTE site.
Thank you, sir. So I'll display the session. The next session will start by 2:20, sir.
Okay. So all the participants attend all the sessions. Thank you.
Yes, sir. Participants are requested to reconnect at 2:10, sir. For the technical, session will start by 2:20.
Okay. Thank you, sir.
Thank you, sir. I'm disconnecting the session, sir.